Hello everybody, my name is Rory Block. I'm under the supervision of Johan Strauss, Dr. Peter Swanepoel and Sarita Bennett. I'm currently doing an MSc at the Stellenbosch University. My trial is here at Jubileerskraal in Swellendam. So we're investigating a precision planter using canola. So we've converted the milli planter into a precision canola planter. We've changed over the plates so that it's a central metering vacuum system that has canola plates that suck the seed on and drop them individually, and to place a uniform seed placement so we can increase yields and profitability.
Just like to give a bit of an overview of what we are trying to achieve here at Jubileerskraal in Swellendam. We are currently going to be looking at the optimal planting density for canola using a precision seed placement method as well as singulation technology. Singulation, what is it? Seed singulation is a central metering vacuum system that can individually separate the seed and place it in the soil evenly to achieve a uniform intra-row spacing between the plants. Singulation is a technology that will help minimize intraspecific plant competition by using the seed placement method that will eventually reduce costs and improve yields. The aim of the study will investigate if geometric uniformity and row spacing can improve canola yield and profitability by using precise seed placement methods at planting. As you can see, we've converted a milli planter into a canola planter by changing the internal vacuum systems and changing the plates. The first objective of the study will investigate whether productivity can be increased using a precision planter under different canola plant populations as well as row spacings in a field experiments. The second objective of the study will investigate the below ground root responses to different plant densities and row spacings. This will be done over my summer in Perth, Western Australia. The third objective of the study will investigate the economic aspects of precision seeded technology to determine if on-farm profitability can be increased. The motivation behind this is that canola is an expensive crop to grow, but technologies can help minimize intraspecific plant competition by using precise seed singulation methods that will reduce seed costs and improve yields. This will be an in-depth study that will investigate agronomic and economic benefits of precise seed placement technology and whether it is an option for growers to consider. There is a need to demonstrate the reliability to growers as well as the economics for them to invest in the machinery and technology. The intent of this research is to improve canola farm productivity and profitability for sustainable future in South Africa. Canola hectares will only increase in South Africa if the agronomy of the crop is well understood and predictable. Demand for alternative break crops and highly priced returns will make canola an attractive crop to grow. The genetics of the cultivars available in South Africa have improved significantly, so we need to keep up with the technology of understanding the different populations, how they react to different row spacings. We need to keep up with that genetics, and we need to understand what these new cultivars are doing in our field experiments, and then we can relay that information over to growers, because it's key to identify the different agronomic practices or specialties that this crop grows under, to then incorporate it into the farm production system. As you can see by the drone visuals from above, just like to give you an overview of what we are doing here with the plots. We have a randomized block design that uses 6 plant populations and 2 row spacings, as mentioned. We will be investigating 10 plants per meter squared, 15 plants per meter squared, 20, 25, 30 and 40 plants per meter squared. Now, from what I understand, is the Western Cape is a recommended rate of 40 to 45 plants per meter squared. That is the general rule of thumb. I'd just like to give a farmer's perspective of how many kilos per hectare that is at planting. So for 10 plants per meter squared, I worked out that the seeding rate would be a 400 grams per hectare seeding rate, and the 40 plants per meter squared would be just under 1.9 kilos per hectare, to give you some reference. So we're really pushing the boundaries on what we are trying to achieve. So if you could get your seeding rate below 1 kilos per hectare, that's a massive saving on your input costs if you get the same yield. From this research, we'll be then looking at data collections and analysis. Firstly, we'll be doing climatic data, which does the weather, maximum, minimum, wind speeds, rainfall, and relative humidity. Also, we'll be looking at plant parameters, which include plant populations, biomass and leaf area index, as well as we'll be then harvesting at the end of the year, looking at seed yield, seed quality, as well as final yield, which we'll all be interested in. From the air visuals, as you can see, we've received very good rainfall this year. Happy with what the trials are looking at this point in time. We're hoping for a good rain this coming weekend, and that will really set us up for the season. On behalf of myself and my supervisors, I'd like to say thank you very much to my sponsors, the Western Cape Department of Agriculture, Equalizer, as well as Stellenbosch University, for giving me the opportunity to do this fantastic research. Also to all the farmers out there, we wish you a fantastic harvest. It's looking to be a fantastic year as well. Hopefully we get some very good yields in the end of it. We wish you all the best, and please stay safe. Appreciate you listening to me talk today, and keep well. Thank you very much.